Okay, this is a little more realistic. I have the top waveform there is the source voltage, 5 volts peak to peak, but now it's at 10 kilohertz. I went from 1 kilohertz to 10 kilohertz. The bottom waveform is the output of the transformer. Okay, now that's at 2 volts peak to peak, so we're looking at about 4 volts. Alright? And they're in phase. When they both go up, they both go down. That previous video where it was inverted and it was 40 volts, I'm not sure, I can't reproduce that. So I'm not sure what was going on there, but this is a lot more realistic of what I would expect from an audio transformer. Now here's there you go, 10 kilohertz, 10 kilohertz, 10 and 50, 10,050 hertz. Okay, close enough. Alright, there's my 3.56, 3. So that's your VRMS on your source voltage. And here's the circuit. Okay. I lost my pointer. Source signal generator comes in. There's my probe for the VRMS, for the voltmeter. This red probe here, the wire. 1 kilohertz, 1 k ohms. The signal goes through the k ohm resistor into the transformer, out of the transformer, but notice that the output is not connected to the circuit. Here's the output circuit. Output of the transformer. Okay, so I know it's hard to see. The output of the transformer is through the brown wire. Okay, the probe that you see on the screen, on the oscilloscope, that's the bottom, is the output of the transformer. Goes through the 8 ohms, two low, whatever they are, 6.8 ohms and 1.2 ohms or whatever, to give close to 8. Out through the red wire, and the red wire is connected in the circuit. So now I have a complete circuit on my secondary. 8 ohm load. Now, here's part of the problem with the voltmeter. Now, I'm doing this on the fly, off the cuff. Yesterday I saw this, so we'll see if the same thing happens. The voltmeter requires current to do its job. Okay, you touch the probe of the voltmeter into your circuit, and now there is current flowing through this wire into the voltmeter. Okay, that means it's affecting the circuit. Okay, now in this case here, the source generator can supply that extra power that's needed to keep the voltage up. Okay, so when I touch the probe to the source connection here, I get a true reading. Now what I want to show you is I'm going to connect the voltmeter to the output circuit, the secondary circuit, which is what you're going to do with your experiment. Okay. Now we went over VRMS. Okay. So according to this here, we're at about 4 volts peak to peak on the output. That's the bottom waveform. Okay. 2 volts peak to peak. I know it's hard to see. It's 2 volts peak to peak. 1, 2. Almost touching the top thing here. 1, 2. Alright, let's just make sure I'm grounded. Okay. So that's across the middle. Alright, 0 volts. Turn that back on. And a little bit less. 3.6, 3.8 volts. Peak to peak. Alright, so you do the math. Let's call it 4. 4 volts times square root of 2, that gives you your VRMS. Okay, so now we're going to get back over here. Okay, that's the source voltage. So if I do a quick calculation, we'll call it 3.8 volts. Alright, so we said 0.707, right, is the square root of 2. Let's just check that. Two y to the x whoops. Let's do this. 0.707 times 0.707 is 0.5. And the 1 over that is 2. So my output voltage is going to be 4 volts peak to peak. Now let's change that to 3.8 volts peak to peak times 0.707. Alright, it's about 2.7 volts. And I'm going to touch my voltmeter to the output of the transformer, and it only measures 1.26. So I said it should be 2.7. It's only 1.26. So the voltmeter is drawing enough current to reduce the voltage of the transformer. And you can also see, obviously, it drops there. If I disconnect, I'm going to disconnect the voltmeter. Connect the voltmeter. This is expected because of the way the voltmeter works. Now, I've also tried other things yesterday to try to see if I could a ground wasn't hooked up correctly. That's another thing too. The voltmeter is connected to the ground. This black one here, this is my ground. All my grounds here go to one place. I have one ground for the whole circuit and the test equipment and the function, but not the function generator. At this point here, the function generator still is only connected to the hot. Okay? When I go to connect the hot, though, or the other side to sort of complete the circuit, right, on the primary, I'm going to connect it now. That's what happens to my output. I'll be honest with you, at this point here, I don't understand enough yet why that's causing that to happen. Okay. Disconnect primary, the source from the primary, the return from the source voltage on the primary, and it goes up to something more what I would expect. And then back to the VRMS, which you're going to be using with your test set up there. Okay, it measures that, but when I take it off, my voltage on the oscilloscope goes back up. Once again, hook up my voltmeter. It's affecting the circuit. Now, the input impedance of the voltmeter should be high enough that that shouldn't happen. So I'm not sure how that works in the context of the secondary on this transformer circuit. Okay. Now, I've done other things before because I've seen, strangeness. If I disconnect which I'm going to do now, I'm going to disconnect the secondary, break that circuit by pulling out the lead from the transformer and secondary out of the circuit. Okay, nothing happens. There's no change. Very, very tiny. Here it's in. here it's out. Here it's in, here it's out. That's a difference of 50 millivolts, which is pretty negligible, especially when you're talking in the single-digit voltage range. Alright, and if I connect the output of the transformer just across the one of the resistors, okay, now you notice how it's different. Okay, it's even lower. Alright, 1.26, that's what I said before. Let me just go back to just the one resistor, which looks like it's the 1.2 ohms. Well, it's the same. Okay, so even the output, the load on the secondary circuit is not making any difference. But why it's dropping, again, I don't know. I mean, I know, but I don't know how. There is a way to fix this, but I have to go back and read the documentation on it. It's a little bit more complicated. But that might be something that I'd have to do. So as far as your circuitry goes, all you're going to want to do is show the change. I think that the fact that the exact voltages you don't need. Okay? You just need to know that, well, your turns ratio, if it's 1 to 1, the voltage on the output should be the voltage on the input. Primary and secondary should be the same. But your voltmeter is going to show differently. Most likely. But we don't know until you actually set it up. However, if you do it this way and you see this voltage drop on the secondary circuit, it's not going to be because your circuit is wrong or things like that, or the theory is wrong. But it's going to be the fact that the voltmeter is affecting the circuit and is taking voltage away, as it were, from the circuit, and that's why we're seeing an incorrect quote-unquote reading. Alright, that's all.